Okay. So basically today we are going to discuss about limits and derivatives. So limit means a value that function is approaching towards at a particular value.
Yes, sir.
Okay. So
Yes, sir.
it is just a approaching value. Got it? So we'll see it by practical examples, then you will understand more. Yeah, in this one, this is function fx equal to 1 when x lesser than or equal to 0 and fx equal to 2 when x is greater than or equal greater than 0. Okay, that function will be like it this one. So if your value x is lesser than 0 or 0, so then function becomes 1. Okay. So
Yes, sir.
if I write, we write limit x tends to 0. We read it like limit x tending to 0 and fx. So that is the value of function, that if x is going towards 0, so where your function is approaching. Okay, that is the meaning of limit. So what we read it like limit
Extends to 0.
x tends to 0 for fx, for function fx. Okay. So
Yes.
here it is written as limit x tend to 0 negative. Okay, limit x tending to 0 and small negative symbol is here. So negative symbol indicates that you have to take value of x some lesser than 0. 0 negative means you need to take the value of x smaller value, the very left to 0. Okay, if you see on the number
Okay,
line,
negative values.
yeah, so left to 0 you have to consider. So left to 0 means,
Yes, sir.
the value of x is lesser than
Nine.
0. The value of x is lesser than 0. So if the value of x lesser than 0, then your function value becomes 1. Okay. So that's why they have written fx limit x tending to 0 negative fx equal to 1. And if I write it plus,
Yes, sir.
if I write it plus limit x tending to 0 plus. So 0 plus means you need to consider x greater than 0. Okay. So if x is greater than 0, so what your function becomes? Function becomes x2. So in this case, they have written limit x tending to 0 plus fx equal to 2. So this what this negative and positive indicates. So the negative and positive, negative is called as the left hand limit. Okay. What it is called?
Yes, sir.
Left hand limit.
Left hand.
And this is called as right hand limit. Okay. Got my point?
Yes, sir.
Okay. So if you have a function and you are going from left and you are coming from right to a particular value of x and you are approaching to the same value, then we say that its limit is defined. Okay. Got it? So for existence of limit, your left hand limit and right hand limit and the function value at that particular point must be same. Got it? So limit x tending to a minus fx is the expected value of f at x equal to a given the values of f near x to the left of a. okay, and plus indicates that you have to
Yes.
take value of x greater than a, just nearby it is, okay. Now we'll see some examples here. It's a function fx equal to x plus 10. It is a function fx equal to x plus 10. So if I put a table for the value of x, so if I put x as 4.9, it becomes 14.9. If I put 4.95, it becomes, so what I am just doing, I am just approaching it towards 5 from left, and here we are approaching 5 towards right, isn't?
Yes, sir.
So if I approach it from left, so it is just closing to that 15. 4.995,
Yes.
it will give you 14.995. If I come from right, so it is giving you
Difference.
yeah, it's a little bit difference, but if we approach towards 5 exactly, so it will give you 15, okay. So limit x tending to 5 negative, that means some just nearby to 5, it is giving you 15, and if you are coming from the right just nearby 5, you will get it 15 again. So that means your limit exists and the function value is also 15 at 5, isn't it? Getting it or not?
Yes, sir.
So if these three values are same at a particular point, then we say that its limit is existing at that particular point. Got my point? Because you have to check whether limit exists at this particular point or not. We'll see the questions, then you will understand it. But basic concept of limit is you have to go from left to that point, towards that point, and you just come closer to the point from the right, and if you are approaching to the same value, then your limit will exist, okay. So just write down this concept, we'll see it, no issues, just a moment. So in all the examples they are showing you that we are approaching to the same function value, okay.
Yes, sir.
Yeah, this question, we'll see this one. Fx equal to x minus 2, and if x is lesser than 0, fx is 0 if x is 0 and it is greater than 0, then it is x plus 2. So first of all we'll find left hand limit, okay. We'll consider point x tending to 0. So we'll find it once it is lesser than 0, and we'll find it once it is more than 0, okay. That means we'll have to find left hand limit as well as right hand limit, got it. So if we are finding its left hand limit equal to limit x tending to 0 negative and fx, we'll write it like this, okay. Now you need to take x lesser than 0 in this scenario, because the value of x is lesser than 0 in this scenario. So if the value of x is lesser than 0, then you have to take x minus 2 function, isn't it?
Yes, sir.
So you need to write it limit x tending to 0 negative, and the function will be x minus 2 there, and now you put x as 0, so what you get? You will get minus 2, isn't it?
Yes, sir.
That means what is the meaning of that left hand limit? That means if you are approaching towards 0 from the left, you are getting minus 2, okay. Now just find its right hand limit. So right hand limit will be limit x tending to 0 plus fx. What will be fx in this case? What will be fx in this case?
X plus 2.
X plus 2, because you are taking x tending to 0 plus. That means you are just closer to 0 but on the right hand side. So if x is greater than 0, that means the function value becomes x plus 2. So you will write x tending to 0 plus x plus 2. So if you put x as 0 here, you will get it 2. So you can see here we are not getting the same value once we approach from the left towards 0, and once we approach from right towards 0, we are getting different values, isn't it? So that means its limit doesn't exist at x equal to 0. Got it or not?
Yes, sir.
Okay. So limit x tending to 0 negative, left hand limit is minus 2, its right hand limit is plus 2. So that will be the function like this. Okay. At 0 it is having 0 value, at lesser than 0 it is having x minus 2 and it is having x plus 2 if x is greater than 0. Okay. So now this question, example number 10, just try to do it for the value of x tending to 1. Just find x tending to 1 fx. Okay. So if we are not getting the same result of left hand limit and right hand limit and the function value at that particular point, so we say that the limit of this function is not defined at x equal to 0. So now you have to test the limit at x tending to 1. Okay. Just try to do it.
Yes, sir.
Did you understand the concept?
Yes, sir. Yes, sir.
Okay.
Sir, so we have to take like first we have to take limit x tends to 1 negative, right?
Yes, yes.
F of x equals to 3
Yeah.
and x equals to 1 and positive f of x equals to 3.
First of all, you have to consider, you need to consider only x equal to 1. Okay, you need to approach x equal to 1 from the left and from the right.
Yes, sir. After that, when you take x equal to 1 and you draw a table and that f of x will be 2.9, x will be 0.9, f of x will be 2.99, x will be 0.9,
Yes,
something
yes.
like that.
Yes, 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 yes. Yeah,
Yes,
but
sir. So, and in the end, you'll get limit x tends to 1, f of x equals to 3.
okay, right. But if the function value at x equal to 1 is 0, that is different. Okay.
Yes, sir.
So in this case also limit is not defined. Got my point?
Oh, okay, sir. Yes, sir.
So what we say, what is our approach, that at a given point the value of the function and its limit may be different. Okay, they may be same, they may be different. If they are different, then even when both are defined, in this case limit is not defined. Okay, and the algebra of limits, if two functions are there in sum, so we can take it separately. Okay, that is a simple algebra. If it is subtraction, then we can subtract the limits as well. If it is multiplication, then we can multiply the limits alone, and in case of division, we take it in division, but condition is your limit extending to a gx must be defined. Okay, that value should not be equal to 0. If it is 0, then this limit will become undefined, isn't? Okay.
Yes, sir.
So now limit of polynomial and rational functions. Limit of polynomials and rational function will do that. So always, if you want to find limit of polynomials, then it always exists. Limit of polynomial is always existing. We'll see that. So polynomial function, let us say you have a polynomial function like this. So where a as the real number such that some number, we know that the limit of x equal to a. Okay, just we'll do it. Yeah, this one. So basically in case of polynomial, we just have to replace x as the limiting value.
So your screen is blurry.
Blurry? How it is possible?
And showing a host, there is low network bandwidth with the host.
Okay, let me check.
Yep, now it's again it's gone.
Just a moment. How it is now?
Yes, sir.
Is it okay? Okay.
Sir, it's gone again. It's showing yellow color near your name. It's showing yellow color and saying low network bandwidth with the host.
But in live stream, I'm getting it clearly.
Sir, you will get mine very clearly because my net is very at 5 points it is.
Okay.
I'm not getting yours. Oh, sir, now it's coming, sir.
Okay, okay. No issue.
Again, it's showing low bandwidth.
So basically, once we are doing just polynomials, so just put the value of your value of x here, you will get it limits. Okay, that means in case of polynomial, it is very simple.
Yes, sir.
You just have to put the value of x.
Yes, sir.
So we'll do examples, then you will understand it. So now this one, limit x tending to 1, x cube minus x square plus 1. So these are the values. You just simply put x as 1, so you'll get it. Okay.
Yes, sir.
So these are very simple one. So in case of polynomial, you just simply put it and you will get the values. Okay. But these are some scenarios. These are some scenarios in which you can find its denominator becoming 0. So if denominator is 0, then this limit is not defined. But that is not the case. That is not the case here in the second question.
Yes.
Okay, if you further factorize it, then the limit of that value, if you just factorize it, what happens?
Sir, I had this doubt. In case you get a whole number, any whole number, not whole number, any natural number in the numerator and get 0 in the denominator, then it's not it's indefined. In case you get 0 by 0, 0 by 0 is 0 only, no, sir?
No. 0 by 0 is another form of limit that is called
So
as.
you need to get 0 by some natural number.
Yes.
And then you can write 0.
Yes.
Okay.
Okay.
Yes, sir.
So just factorize it, x cube minus 4x square plus 4x. So you will get it x as common, x square minus 4x plus 4, and here you will get it x minus 2 and x plus 2. Okay. So that can be written as x minus 2 whole square x minus 2 and x plus 2. So now you can see that it's x minus 2 is cancelled now, and if you put now x tending to 2, so you'll get it 0 at numerator and 4 in denominator, so it is 0. Okay, so just try to remove 0 from the denominator. That is the main idea once you got algebraic functions in numerator and denominator both. Okay, now just try to do third part, because if you put 2 here in denominator, it becomes, I think, 0.
Yes, sir, it will become 0.
Yeah, so you need to remove, you try to remove it. Okay.
Oh, okay, sir. First, you have to factorize it only, I think.
Yeah.
X plus 2, x minus 2 by x common x square minus 4x plus 4. This will also become x minus 2 whole square. X plus 2 x minus 2 by x into x plus 2 x minus 2. X minus 2 cancel. Become. Sir, this will come 4 by 0, no? This is not defined anyway. This limit is not defined.
Why?
So it's coming 4 by 0. Check. Can you check once?
4 by 0. So that's why I told you just try to factorize it.
Yes. Sir, I did, sir. Once, can you check in the answers?
Yeah, 4 by 0. If you're getting it 4 by 0, that means undefined.
Yes, sir. It's no way. There's no way you can define it. After factorizing only, it's coming 4
Yeah.
by 0 again.
Yes. So it is undefined.
Yes, sir. Should I do the fourth one, sir?
Yeah, please.
Like, x tends to 2 x cube minus 2x square minus 5x plus 6 is equals to limit x tends to 2 x square x minus 2 by x minus 2.
If you're getting it 0 by 0, then you just try to factorize it and try to remove that. Okay.
Yes, sir. Yes, sir. Sir, is it minus 4?
Yeah, it is minus 4. You're right. Now
Fifth one.
just do fifth one.
Yep. Limit.
Fifth one, you need to simplify it all.
Yes, sir. Yes, sir. X tends to 1. X minus 2. X minus 2y x square minus x.
Done it or not?
1 second, sir. Sir, I'm getting 2.
Yeah, 2 is the right answer. Very good. It was a little bit complicated one because you need to solve it all. Okay. Yeah. Now this one, if you have limit x tending to a, x to the power n minus a to the power n divided by x minus a, so you will get na to the power n minus 1. Just write down this expression because you need to use it as a formula. Okay. Done?
Yeah, sir.
Okay. Now we'll see it how it is derived. So it is basically by dividing x to the power n minus a to the power n by x minus a. So we see that x to the power n minus a to the power n, I can write it like this, x minus a into x to the power n minus 1, x to the power n minus 2 into a. So this on to a to the power n minus 1. Okay. Now just take x minus a that side and put limit x tending to a on both sides. So you will get it. If you put x tending to a here, so you will get a to the power n minus 1. What is that? Up to n terms. So that becomes same terms, you are getting it again and again, a to the power n minus 1, a to the power n minus 1, and it is up to n terms. So you will get n a to the power n minus 1. Got it?
Yes, sir.
Okay.
Yes, sir.
Now this formula you just have to use it in this example 3. Just try to do it.
X to the power 15, x to the power 10 minus 1.
Now something you have to introduce in this question. What you need to have in this question? X minus a is missing. X minus a is missing, isn't?
Sir, it'll be okay. Yes, sir. Yes, sir.
If I use that formula, limit x tending to x to the power n a to the power n divided by x minus a, x tending to a. So you can observe here it is only x to the power 15 minus 1. So x minus a is not there. So what you will do? You just divide x to the power 15 minus 1 divided by x minus 1, I can write, and here it is x to the power 10 minus 1 and divided by x minus 1. Can I write it like this? Isn't it? Okay, and it is just a quotient, so I can write it in separate, limit x tending to 1, x to the power 15 minus 1 and x minus 1, and limit x tending to 1, x to the power 10 minus 1 divided by x minus 1. Isn't it?
Yes.
What is the value of this according to the formula? It is n a to the power n minus 1. What is n in this case? In this case n is 15.
10.
15.
Oh, okay, okay. Yes, sir. Yes, sir.
So it is 15, and what is a? A is 1. Okay.
Yes, sir.
So 15 and a 1 to the power 14.
Yes, sir.
And here in below it will be 10, 1 to the power 9. So that will be 15 by 10.
Yes, sir.
So that will be 3 by 2. So 3 by 2 will be the value of this function. Okay.
Yes, sir.
Okay, now try to do second part. Second part is also like some little bit complex one. Just try to do it.
Okay.
And even you can change the limits as well. You can change the limits. Okay. So here change of limit is there. Okay, no issues. I'll explain it. Don't worry. You might not be able to do this question because here is the change in limits. Okay, just look it here.
I'll do it, sir.
Okay. Just try.
I'll try.
But little bit hint that you have to change the limits.
Okay, sir.
What sound is coming here?
Sir, in my apartment, they're doing some
Okay.
construction work.
Okay. 30 है ना?
What, sir?
No. I was not saying something. I was saying something to my son.
Oh. So you have to take it by in like 1 plus x. You have to take it as another term like a, right?
Yeah. If
A
you
equals to 1 or something.
if you take it y, let us say 1 plus x is y. Okay.
Yes, sir.
If you take 1 plus x as y, so x becomes y minus 1. Okay. And
Yes, sir.
what your limit will be? In case of x it was 0, but in case of y it will be x tending to 0, then y will be tending to 1. If you put x as 0, you will get y as 1. So that means your limit changing from 0, x tending to 0 to y tending to 1, and your 1 plus x is changing to y, or x is changing to y minus 1. Okay.
Yes, sir. Yes, sir. So you get 1 by 2.
Yeah, 1 by 2 is the right answer. Okay. And you need to
Yes, sir.
replace it again in terms of x, because you have changed the limits as well. Okay.
Yes, sir.
So if you have changed the
Yes, sir.
limits, you need not to replace it again in terms of x. So I hope you understand the concepts of limit.
Yes, sir.
Okay. So once we have limits of trigonometric functions, so you are aware, I think we have just finished the trigonometric functions. So in trigonometric functions, what was the limit of sine? That means sine can't be going beyond 1, and it can't go beyond -1. Okay.
Yes, sir.
So
Yes, sir.
if let f and g be two real valued functions with the same domain such that fx is lesser than gx for all in domain. Okay, yeah, no issues, we'll do some questions directly. Okay, now this one, limit x tending to 0 sin x by x, you need to remember it is 1. Okay.
Yes, sir.
This thing you can use it as a formula. Limit x tending to 0 sin x by x, you will get it 1. Okay. And this one, limit x tending to 0 1 minus cos x by x, if you put x as 0, you will get it 0 by 0, isn't it?
Yes, sir.
But this is equal to 0, this limit is equal to 0, that you have to remember it. Okay. So these two formula is for trigonometric functions. Have you written it down?
Yes, sir.
Please write. Okay. And the second one, is 1 minus cos x. It was 1 minus cos x by x. So I have written, you just have to remove this 1 by using cos formula. So it will be 2 sin square x by 2 and divided by x. So what we are writing, sin x by 2 by x by 2, and it is sin x by 2. So we can use product rule of the limits. Okay. So its limit is 1. Limit x tending to 0 sin x by 2 by x by 2, its value is 1, and limit x tending to 0 sin x by 2, its limit is 0. Okay. So we have used the first one formula. Got it?
Yes, sir.
Okay, now these questions you need to do it by using this single formula, limit x tending to 0 sin x by x equal to 1. You can use that one.
Yes, sir. So I'm getting 2.
Okay. For the first one,
Sin 4x by sin 2x.
yeah, it is 2. It is right answer. It is. Now just do second part.
Yes, sir. So tan x by x. So I'm taking it as 1 by cos x.
Okay, but if you put x as 0, cos 0 will become 1, so you'll get it 1, isn't it?
Yes, sir. Yes, sir.
Okay, so its value will be 1.
I said 1 by cos x directly because then sin x by cos x, if we do it, become 1 by x into sin x by cos x. So sin x by x equals to 1 by.
Okay.
So I did like that.
Okay, no issues.
Yes.
Okay, first one is very simple, second one is also simple, third one is also simple, fourth is also simple, Fifth one is also simple. Okay, just try sixth one.
Okay, sir. So we get 0 by 0, so you have to do it another way, right?
Yeah. We'll just try to remove it. Do you remember we came across this type of question in
Yes, sir, we
examples
have to
also?
take excess on as another variable.
Yeah. You need to change the limit. And wherever you are using formula, just write down at the right of it.
Yes, sir. So are we getting in that x to the power n minus y to the power n, a to the power n form?
Yeah, please.
So we use formula then.
Yes.
Sir, is it 5?
Yeah, 5 is the right answer. Okay. Now do seventh.
Seventh one?
Yeah.
3x squared minus x minus 8 x squared. Wait, x plus 2, x minus 2, 3x squared minus x minus 10. Into x minus 2 into so 11 by 4?
Yeah, 11 by 4 is the right answer. You're right. Now go for eighth one. Factorization will work only when you have 0 by 0 form. Okay.
Yes, sir.
So if you are getting 0 by 0, then only use factorization. Otherwise, it's not necessary.
Okay, sir.
So it is better to check before factorizing. And these are genuine questions. These are genuine questions. They will be asked in exams. Okay, they're very important.
Yes, sir. So is it 108 by 7?
108 by 7. Yeah. 108 by 7 is the right answer. Yeah, right. Yeah, go for the next one.
Ax plus b by c. So isn't it simply b?
Yeah, right. Simply it is B. Next one.
Because this is that a and...
Yeah, the same question we repeated in the exam.
So this will be square, right?
No, it's,
1 by 6 square, whole square is 1 by 3.
it is z to the power 1 by 3. It is z to the power 1 by 6.
Okay, my bad sir. I forgot. You need to divide both numerator and denominator by z
Yeah.
minus 1 by 3.
Yes.
Okay.
Done.
Yes, sir. I'm so sorry. I just had to get my charger.
Okay. Is it done? Have you done 10th one?
Sir, it's 1. 10th one. 10th one I got... I'm done with the 10th one. I was doing the 11th one. 10th one I got 2. 11th one is 1.
Okay, right. 10th and 11th. Both are right. Okay. Good. Try this. Hello. गुड इवनिंग. आप कौन? बढ़िया. मैम मैं क्लास में हूँ, अभी करता हूँ आपसे बात.
So is it minus 1 by 4?
Yeah, minus 1 by 4 is the right answer. Okay, next one.
Sin ax by bx. You have to take a by b outside, right?
Yeah, if it is necessary, then you have to take.
I mean, like, so we have to take, first of all, you have to take sin ax into 1 by bx, and then we have to multiply it with sin ax.
Yeah, because you need to keep it a here. Okay. So if you want to a here, you need to multiply it like this, but this b you have to take it outside. Then limit x tending to 0 sine ax by ax. Okay.
Yes, sir. Gets cancelled, so it will become a by b or limit. Sir, it's just b by a.
B by
sorry, a by
a by b, a by b, a by
Sorry,
b.
sorry, b by b.
It will be a by b. Okay, just do 14th now.
14th one. Sin ax bx limit x tends to 0. Limit x tends to 0 sin ax. Become 1 into ax sin then dividing by become a by b. Divided by x bx by bx become by. Sir, it's a by b again.
Yeah, right. A by b again it will be. Okay. So the remaining questions,
Okay.
the exercise is very long. It is up to
32.
32. Okay. So the last questions are very important. Okay. Like if they have multifunctional values, so they are very important one. So these questions, just try to do it. If you have any problem, then we'll discuss it in the class next session on Wednesday, the same time, 3:30 p.m. Okay. If you will have any doubt, then we'll solve it. Otherwise, we'll do derivatives in the next session.
Okay, sir.
Okay. Okay then, Moksha. Bye bye. See you.
Thank you, sir. Bye, sir.
Welcome.